Great. So the plan for today's live lecture is we looked through the quick check questions from lecture 5 and lecture 6 that students tended to get wrong, and we've put together a nice little demo in Pandas working through some NBA data that will address most of these misconceptions. Now, we will post this code on the website after this live lecture session, so you can play around with it on your own. But we chose not to post it before the live lecture session because there are a lot of things in here that we want you to think about, before we actually run the code together. But you'll be able to play around with this on your own. And if we have time left at the end, we will work through some regular expressions problems that are linked on the resources page of the website. Okay, any questions with anything before we get started? About the class, about what we're going to do in live lecture, anything? No worries. No worries. Okay. If there are no questions, we'll get started. And I want to encourage you again to turn on your video, or if not, be active in the chat, because there will be a lot of interaction and back and forth in this lecture in particular. So let's get started. So we have this NBA data set that I got from basketballreference.com. You will actually see this exact same CSV appear in like two more labs that will come out later in the semester, so you'll be familiar with this. But essentially, this has the season averages for all of the players in the National Basketball Association in the 2018-2019 season. Okay, so we've used pd.read CSV to read this in as a data frame, and now we will start playing around with it. So one misconception that students had was that many students put that they felt that indices in a data frame had to be unique, and that's actually not true. Most of the time it will be true, and we tend to prefer that to be true because we use often indices as being primary keys, sort of, but indices don't need to be unique. In the data frame that we've read in here, the index is just 0, 1, 2, 3, 4, so on and so forth. And usually when you use pd.read CSV, this is what the index becomes by default, I believe. But I've made a copy of this data frame. I called it df2, which is df.copy. And I set the index of this new copied data frame to be just a list of ones. So now every index in this new copied data frame is equal to 1. So this is showing you that indices don't need to be unique. Any questions with this? Does that mean we have to use iloc in this case? Great question. The next exercise that Alan is going to work through will show you how loc and iloc work in the case of this specific data frame. So Alan, want to go for it?
Yeah, great question, by the way, because that's literally what's coming next.
Yeah.
Yeah, so first, loc and iloc. So this is like generally one of the concepts that students are most confused about when we do pandas. But I think it's best to go over some examples to see like exactly what the difference is. But the general like idea is that like loc, like it starts with the L, so that think like labels. If you're using loc, it's like labels. If you're using iloc, it starts with the I, so think like indices or like integer locations. So like when you use iloc, you should always use like integers as your like arguments. When you use loc, you should almost always use like actual labels, except like sometimes your labels happen to be integers, so then you can use integers. So like the first example here is like suppose we wanted the people who, or the players that average more than 10 points a season. So there's actually like two ways to do it. To do this, you can use loc, or you can like filter and then like select the column. So the way that is presented here is just using loc. So the first argument here is like a Boolean array of like trues and falses, whether the points are like greater than 10 or not. And you can use that as the first argument of loc, and that'll filter out the rows that have the points that are less than or equal to 10. So that's one way you can do it. You could also do like df bracket df pts greater than 10, like separately, and then it's kind of hard to do this without
Yeah,
like that, and then select the player column afterwards. So both are equivalent. It's just however you want to do it, basically. So that's one way you can use loc, like use the Boolean array as the first argument, and the second argument is like whatever columns. Another way you can do it is like actually selecting the labels instead of selecting like a Boolean array for the rows. So this line of code here is df.loc 4 to 14 age to FGA. So how many, first question for you guys is, how many rows do you think this would output? Like 10, 11, 12, 13, 700?
223.
11, 10, 10, 11, 11, 10. Great. Okay, those are the two most common answers. Okay. So the important thing about loc is that you're selecting labels. So essentially what loc is looking at here is I'm looking for all the labels between 4 and 14 inclusive. And since there's no like integer indexing like inherently what's the word for it? Inherently like built into loc. Loc doesn't know like, oh, I need to exclude the last one, because loc is just looking at the labels themselves. So 4 to 14 just means I'm looking for the row with label 4. I'm taking everything until I get to label 14. So let's see. Yeah, so I'm just taking label 4 here, which is kind of weird because there's this RK column, but the index is like the leftmost thing.
Yeah.
Leftmost column. So it's looking at the index with label 4, which is the 5th row here. And it's taking every row from that row to the row with index label 14. And so it's taking those 11 rows. So if you like just run that.
Well, let me run it first.
Yeah, without
this stuff, because that's an argument or a conversation.
Yeah. So the second argument is like the columns, and if you just do colon, then you'll just take all the columns. But you'll see here like it's 4 to 14, the label 4 to the label 14, and all rows in between. So that's all 11 rows between 4 and 14. Any questions about that? Why it's like not inclusive? I mean, it's kind of like built into loc, but any questions?
Why it is inclusive, you mean?
Yeah, why it is inclusive, sorry.
Sorry, so just to make sure, if you don't use .loc, you'd have to use 2 sets of square bracket parentheses.
2 sets of square bracket parentheses.
To index out the rows and the columns like you did, I think, one cell above without the .loc.
Yeah, so can you do df bracket 4 colon 14?
Yes.
I think that's the question.
And then once again,
so it actually does, it looks like it actually does like iloc in here, because it's when you do that, it implicitly thinks they're indices, or like it goes by this is kind of confusing, but like without doing loc or iloc, and you just use slicing, it just thinks of those as indices. So 4 to like row 4 to row 14, but not including row 14.
Okay.
Because I mean, it's just the way like that it's like built in, that if you just do it without loc or iloc, it just kind of assumes that you're slicing with like iloc syntax. Okay, let me get to the questions.
I would recommend not doing this, just because it's ambiguous what the return value would be. Pandas is quite messy if you haven't already, picked up on that fact. So you want to try and be as explicit as possible, so that this could be anything. So you don't want to do things like that.
Yeah, I would definitely recommend actually using loc or iloc instead of
yeah.
Okay, so wait, hold on. Does loc work with pivot tables? Yeah, so pivot tables are pretty much just data frames as well. They're just they just have like indices that are not necessarily numbers. They might be like some label, but you can still use loc with them. So if we sort by something 4 to 14 doesn't always return 11 rows. Yes, that's correct. Is there a way to demo this? I would demo this, so it's kind of, I don't have.
Sure, no, let's do it. Let's see. df.sort values PTS, let's say, .loc 4 to 14. So does anyone know why this happened?
Yeah, that's a good question.
Yeah, I'm glad you asked that. Why did this happen? So again, I'm sorting by the points column, and you can see, you know, I have all the people who scored 0. Yeah, so I'm pretty sure what you said is correct. Row 14 comes before row 4 here. So if I instead change this to be 14 to 4, it'll give me everything between 14 and 4.
And yeah, you'll see that it's 35 rows now, not necessarily 11 or whatever, because that's how many rows that there are between 14 and 4 in this case.
Great question. I will add this to the bottom of the notebook before posting it. To do, add this. Great question. Okay, let's go through what was
sorting
here.
Maintains the underlying indices. Yeah, so the row stays the same, but like the rows get shifted around based on like what you're sorting on.
Yeah.
But like the index doesn't change. And if you wanted to like reset the index so that like it's back to 1, 2, 3, 4, whatever, you can do .reset _ index. And then okay, so back to the. Okay, hold on. One more question.
Moment of suspense.
Moment of suspense. So how do we get the 4th to 14 row? I think you're thinking of iLoc.
You're thinking of iLoc, yeah.
Yeah,
we're getting there.
We'll get there. So yeah, okay. So the columns, yeah, so the columns kind of work the same way. You can select either one column or like a list of columns, or you can do like this slicing thing. It's not really slicing, it's more like I'm getting everything between age and FGA, inclusive of age and FGA. And another reason you can think it's inclusive is that, like, imagine you're trying to get like imagine if it were exclusive of the last thing, then you would have to like figure out what the next column is, and that's just annoying. So it kind of makes sense that loc would be inclusive in this case, that it would include the age and the FGA. So yeah, it would get the age column and then everything in between, and then the FGA column. So it gets everything in between age and FGA, including age and FGA. All right, so that's loc. Any more questions on loc before we get to iLoc? All right, so iLoc is very similar to loc, but again, iLoc is index using like integer locations and like index. It's closer to Python indexing essentially. So there's this line of code here: df.iloc 4 to 14, 3 to 10. So first question is, again, how many rows would this output?
Nice.
And nice. So yeah. So okay, I guess let's ask how many columns would this output first before we spoil things. 7.
They're too good.
They're too good. Yeah. Okay. So you're exactly right. So 4 to 14, I select all row. I select the 4th row up to the 14th row, but not including the 14th row, because this is Python indexing now. So I don't include the last index or the last thing. Similarly for the columns, I get the 3rd column all the way to the 10th column, but I don't include the 10th column because we're using iLoc. So you'll see like the age is the third column, and then FGA is the ninth column. So it doesn't include the 10th column. And then you'll see it doesn't include index 14 either.
The question that was asked, the following example is about to answer it.
Yeah. So remember we had like this weird DF2 that had like the 1 as the index instead of like 1, 2, 3, 4, 5, 6. So what happens if we run the exact same code as before? Like, is the result the same, or does something change compared to df.ilook? What happens if we do df2? Got one same. Same question mark. Same double question mark.
I gotta contribute here. All
right, yeah. So because we're using ilook, it's just looking at integer locations. So df2, the only thing that changed was the index. None of the locations of anything changed. So there's no reason for ilook, the result of ilook, to change, because ilook is just looking for like the integer indices of things and the location of stuff. So there's no reason for ilook to change. But what's the next line? Okay, that's what I was expecting. Whatever. ilook 1, so that just gets the second row. So 0 would be the first row and 1 would be the second row. So that just gets the second row. So that's just an example of using ilook with like one argument essentially. So this would just take this all of the columns in the second row. But if we do look, so before swallowing this, how many rows would this output? So ilook 1, you're just selecting one row because you're just like selecting the second row. But what happens if we do loc 1? How many? Okay, I guess first thing, this is df2, not df. So this is the one with the indices that have all the indices are 1. So how many rows would I get? Would I get all of them? Would I get some of them? Would I get only 1? Would I get 0?
Too many.
It's all great. All right, so yeah, you would get all of them because the index for all of those rows are 1, and loc just looks for the index labeled 1, and all of these rows have the index has label 1. So it's just select all of the rows. If I did df2.loc anything else, then nothing. There would be no rows in the output because none of the rows have an index that is not 1. Or I guess the key error. It wouldn't even output anything. All right. Any last questions on loc versus ilook before we get to stir methods? Why for ilook 1 the series index are the column names? Can you go back to ilook 1? Yeah, that's just the way that Pandas works when you're just doing ilook on one thing. So if you do ilook 1 to 2 or 1 to 3, try that. Yeah, so then it'll give you like the data frame. But when you're only selecting one row, Pandas just thinks, oh, I don't need to like actually make a data frame with all this stuff. I just have one row, so I could just make it a series. So it's kind of weird in that sense.
This is some edge case behavior.
Yeah.
Right, this is technically one row, but because we used this slicing, it gave it to us as a data frame. So, Pandas is just weird. And after experimenting with it, hopefully you'll pick up on these patterns.
What if all the indices are unique and you do df.loc1? You want to try that?
Sure, yeah.
df?
Yeah, I mean, df, all the indices are unique, and we can do that. You just get the row whose index is equal to 1.
I prefer just square brackets location. It's just more readable, in my opinion. When you do df, like bracket something, you don't know if you're like selecting rows or columns. So it happens to be the case that when you're doing df with a slice, that it actually selects rows. But when you do df with like just one thing, then it selects columns, or a list of things will just select columns.
So these are inconsistent.
Yeah.
Right? Here we pass just one thing into df, it's giving us, all these rows. Here we passed one thing in and it's giving us a column. So this is a little ambiguous, and that's why we like to use look. Okay, let's move on out of interest for time. Another misconception that a lot of students had, and there was a nice discussion about this on Piazza, is using .str methods. And so let's take a look at the player column in our data frame. You can see we have the name of a player. So for example, Steven Adams, and then a backslash followed by some weird, code. And this code is probably, what Basketball Reference, I believe it's what Basketball Reference makes the URL for the web pages for all of these players. And you can think of these as being a primary key. So if there were two players named Steven Adams, one of them might be Adams ST01 and the other one might be Adams ST02, for example.
Technically not true if you look at Ivica Zubac, because
this is all the same player.
Yeah, but it's not technically a primary
I see
key
what you
in this
mean.
case.
It's unique to a player. These are all the same Ivica Zubac. It's just that he got traded from the Lakers to the Clippers in the season. So one row, if you look at the data, one row corresponds to the Lakers, one is the Clippers, and one is total. But anyways, that's not really the point of this. What we want to do is just get the name of the player before the backslash. And so what we can do is use .str.split. And if I do that, what it does is for each element in this series, it splits each of these strings by the backslash character. The reason I had a double backslash is because you need to escape the backslash on its own. I don't believe it works if you use a single backslash. Yeah, you get this weird error because the backslash is not escaped. So we need to use a double backslash here. And so my question is, what if we want to just get the names of the players? So the first thing in each of these lists. What should we do? So if I just want Alex Abrines, Quincy Acee, Jalen Adams, Steven Adams, Bam Adebayo, so on and so forth. How do I go about doing this? Okay. So one option is to use square brackets 0, and another option is to use .str0. Let's look at what happens when we do both of them. So let's see what happens when we just use square brackets 0, right? Why can we do this? Well, the result of calling .str.split on this thing is a series, right? This thing that we are visualizing here is a series. And so when we do square bracket 0, what it's going to do is give us the first element in this series. This is a series of lists. It will give us the first thing. So if we instead want to get the first element of each of these lists, we need to use .str again. And that will work the way we want it to. Okay, and this was a question on the quick check that quite a few students got wrong. What's the intuition for STR? Great question. The way I like to think about it is if by default, the slicing you use applies to the entire series. If you do .str, the slicing you use applies to each of the elements of the series individually. Does that kind of make sense? It was a pretty bad explanation, but let's experiment with something. And to be honest, I'm not entirely sure if this is going to work. But let's say we take the player column and do square bracket 0. It's going to give us Alex Abrines because he's the first player that we have. What do you think should happen if we do df the player column .str0? Anyone have any ideas? Yeah, it's going to give us the first character of everyone's name. So when we, put a .str there, it says, don't apply this slicing or indexing to the entire series. Instead, apply it to each element of the series individually. Great. Can anyone think of a way to replicate this behavior without using str methods? Great. Yeah, you can map or apply. Let's do that. I personally like using apply. I don't know why, but let's apply. And you're saying, let's create a lambda function. So what we want to do is write a function that takes in a string and only gives us everything before the backslash. So how can we do that? Any ideas? How can we take in a string and return only the things before the backslash? Anyone know how to do that? Great, great. We're digging deep into the 61A knowledge here, but it's X. What we want to do is find the index of the backslash. So for example, let's just say we have abc.index of b. This will give us 1 because that's the position at which the b occurs. And so x.index backslash, we need to use double backslashes again here, will tell us where the backslash is. And what we can do is index into the string x using this index, right? Because x.index of backslash will just return a number, and we want to get the entire string just up until that position. So what I can do is, just put colon right before this, because this will say, give me everything up until, this character in the string. And we know that Python slicing is exclusive, so this should work just fine. And it does. Okay. We'll save this because we're going to use it in example 6, but we're getting
Quick note.
Yeah.
You can also use regular expressions to do this. But
yeah, you could, but we leave that as an exercise.
We'll leave it as an exercise.
Yeah.
Also, you might want to think about, as an exercise, how can we get the first names only using stir.split? We already have this thing. Now what if we just want the first names?
Well, so one thing you could do is just do this again and do it on the index of the space. But there are more elegant solutions to this. And this is probably not how you should write code.
Yeah. You can just do stir split again.
Yeah, exactly. Okay, let's move on and talk about grouping. So one thing we really want to stress, and most people got this on the quick check, is that the result of calling .groupBy is not a data frame or series. It's a pandas.core.groupby.generic.dataframe groupby object, which is exactly what we get when we do df.groupby. Here we're grouping on team. In order to get a data frame at the end, you need to filter or aggregate using some sort of aggregation or filtering function. Okay, so what I want to ask is, what will this line of code do? So I'm sorting by points. Ascending is equal to false, just means descending is true. So I'm going to rank all of the players by the number of points that they averaged in 2018, 2019. And then I'm grouping by team, and I'm aggregating with this weird lambda function. What is the result of this going to be? Great. So this will tell us the highest scorer on each team. Why? Why is that what this will give us? And you're right, that's what it does give us. But why is that what this gives us? Stable sort? Not quite. It has to do with the fact that we sorted, yeah. Exactly, yeah. So essentially what we were doing when we group by team is we take all of the players for each team and we need to, aggregate those values somehow. Since we already sorted our entire data frame by points, we know that the first player that we look at on each team scored the most points for that team. And so we get, the points per game for the highest score on each team along with the player's name. And so you should realize that here, the points per game and names match up properly, right? Like LeBron did average 27.4 and Giannis did average 27.7, for example, right? Here, we sorted by points and just took the first player, and the rest of the rows correspond to that player. Maybe wondering why I'm emphasizing this right now. Well, it's because we're about to look at an example where some funny business happens. But before we do that, I want to just note that instead of writing this custom aggregation function that takes in a series and just returns the first element of that series, you can also use dot first, which just takes a series and also just gives you the first element. So using dot first and whatever this custom aggregation function is are the same. There's a question: why isn't the resulting table still sorted by points? Does anyone have an answer to that? Great question. Why isn't it? Yeah, so it turns out here that it's sorted alphabetically by team. Yeah, it's because we aggregated by team. So for example, let's say for the Atlanta Hawks, ATL, we took all those players and took the highest scoring one. Then for all the Boston players, we took the highest scoring one, and so on and so forth. There's nothing, we never told it to then resort by points per game after taking the highest score per team. If we wanted to, we could just again say sort values, points. We never explicitly told it to do that. Is that clear? Why is team automatically sorted by alphabetic order? Great question. I'm pretty sure that's just how grouping works. I could be wrong on that though. Alan, do you know?
I'm not sure, but I think that's how grouping works too. It just like gets the groups together and like somehow orders them. Because if you look at the original data set, I think.
Let's try another example. So let's group by position. Yeah, it is just always alphabetical. Right here I group by position, and the things that start with a C are first, then the P's, and then the S's. So for whatever reason, that's just, why Pandas does it. It is because team becomes the new index, but there's nothing saying that the index needs to be sorted.
Yeah, and definitely if you look at the original data frame, that's not necessarily the order, like the things came in. Like the center came first. It just happened to be like the first row of the center, but that's not what happened.
Yeah. Okay. What does this line of code do? So instead of sorting and writing my custom aggregation functions, you may say, hey, wait a minute. All I'm doing is just taking the highest scoring player from each team. So why can't I aggregate with max? Why can I not do this? Great, because it's applied to each column individually. So what this does is it does give me the points per game of the highest scorer on each team, right? If you look at the points per game column, it's 19.5, then 23.8, then 21.1, and so on and so forth. Those numbers are right, but everything else seems a little off. What it does is it takes the max of all of the columns individually. And so you can see here, what it's done is it's taken the last player on the team alphabetically. And so that's why you see a lot of V's and T's and Z's and W's. That's how Zaza Pachulia ended up here. Like he didn't average 24.5, right? The case of Stephen Curry, I think it turned out to be true because he did average 27.3. But like in general, this took the, max of each column individually. And so that's why all of the positions are the same. They all happen to be shooting guards. So is everyone clear on why this is wrong? Great. Couple last examples. What does this line of code do? What does this line of code do? Oh, there's a question. Can you explain it once again? What specifically would you like explained again? I'd be glad to, but yeah. Cool. Yeah. What does this line of code do? It looks very similar to the ones we had before, but it's slightly different. Chaos. It looks like chaos to me. It errors because you can't sort after grouping. If you want to sort, you need to do it before grouping or after you group and aggregate. You can't sort values on a df.groupByObject, right? This isn't a data frame. In order to sort values, you need to have a data frame or a series, I believe. So that's why this doesn't work. As the last example, let's take a look at how we can, get a data frame after grouping without using an aggregation function. So let's suppose we want to determine the names of all of the teams whose highest scorer averaged less than 25 points per game last season. So what I've done here is I'm again grouping by team, but instead of aggregating, I'm filtering. What I'm doing is I'm saying, take in some object X and, return true if the max of the points, field of X is less than 25. What kind of object is X here? What is X here? Okay, one person said data frame. Any other ideas? Subframe. Yeah, so this is a data frame. The reason I'm pointing this out is because when we used apply before, let's see where that is. Yeah, when you use .apply and things like that, well, I guess you can use .apply on rows as well. But the way we use .apply here was that it would, well, here it's only taking in just one element of a series at a time. And aggregation functions take in an entire series at once, right? So this is taking in a series and giving you just the first element of it. Filter, where are we at here? Filter takes in a data frame, and it's keeping only the data frames whose maximum value in the points column is less than 25. So what does this result give us? What's going on here? Can someone interpret this? I wanted the names of all the teams whose highest scorer averaged less than 25, but I have 452 rows. Only 30 teams in the NBA. So what's happening here? What is going on? Great. Yeah. So this data frame only contains the teams whose highest scoring player averaged less than 25, but it has all of the members of those teams. So if we want to get just the names of the teams, I could look at the team column, but that still has 452 elements. So how can I get just the team names on their own? Does anyone know? Dot unique. Great, great, great. So now I have just the names of the teams whose highest scorer averaged less than 25 points per game last season. Great. Someone said that we could use that value counts. Let's take a look. We could, but this just tells us the number of players on each of these teams that are in the data frame. If we want just the team names, you could do dot index of this, right? Because value counts as a series. If you ever want to take just the index of a series, you can say dot. Great, 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 great. Cool. Let's move on. Alan?
Yeah. One quick note. What you saw there was kind of like an argmax query. We're trying to find like the player with the highest score. So like that type of thing is like much easier to do in Pandas than SQL, as you saw. Like you can just sort and then group in Pandas. But in SQL, you can't really, after you group, you can't really like select the first row or anything like that. So that's something that's like a slight subtle difference between Pandas and SQL. Like an argmax query is really difficult in SQL compared to Pandas. Just one thing I want to note before. So we can also group by multiple columns. You don't have to group by only one thing. So there's this line of code here, df.group by tm pos dot mean pts. So what does that do? Like compared to like grouping by just tm. Two indices. Yeah, so all unique combos of teams and pos. Yeah, so when you group by team and pos, then you would get all unique combos of team and position. So players on, yeah, you run, yeah, So what was the column you selected? Points or something? Okay.
Yeah, sorry, I just removed that so we could see what the entire.
Yeah. So you get like a double in like this is called a multi-index. So originally when you just grouped by team, your index was just team and there was just like one column, the team. But here like we kind of have two columns as the index, but it's not really two columns. It's kind of like a combination of two columns. So you have ATLC, ATL PF, ATL PG, ATL SF, ATL SG, WASH C, and like all those possible combinations of TM and POS as your index essentially. And the dot mean does like the same thing as it does like in the single group by case, where you're just taking the mean of the points of all the at like the centers for ATL, for example. That would be like the first row here, and the second row would be like the mean of the mean. It's kind of weird because it's the mean of the average of the season, the mean of like the season average of the points. But just think of it as like the mean of the points for all the power forwards in the Atlanta Hawks. So that would be that thing. Ignore what I said earlier. I'll just get you more confused. It's the average of the of how many points Atlanta power forwards score. So there might be like 2 or 3 Atlanta power forwards, and it would just take the average of those 3. Okay, so now we have like a more like we have this like this kind of like a series but with like multi-index. So let's say we want to like try to select things in this series. It's kind of there's like a multi-index, so it's kind of hard to select things. So what would this do if I have this series and then I add in like this another bracket with ATL and SF? So what number would that output given like the output of the previous series? 6.9. Yeah, so that's exactly what I would do. So ATL here essentially selects the first how do I say it? The first of the first column, which is team. It would select the ATL as the team, and then SF would be like what it selects for the second part of the multi-index. So ATL for the first part of the multi-index, which is team, and SF for the second part of the multi-index, which is POS. So if I wanted to select all the positions for ATL, what could I do? Like what would need to change? So remember, colon helps you like select all the positions. So I think, yeah, ATL only. I think that would work. Yeah, so that would work. Or you can do ATL, comma, colon. And that was, oh, wow. What? What?
I wasn't expecting that.
I was not expecting that either. What the heck?
Okay, so I guess you have to do this.
I guess you have to do that. If you do .loc,
I don't believe .loc works here.
.loc doesn't work. The reason it doesn't work is because you have a multi-index. So you can use .loc, but the first argument in your .loc would be like a list of 2 things. So if you do, you can.
Let's experiment here. This is
You can do .loc, but you would have to do.
Would this work?
Yeah, I think that would work.
Whoa.
Yeah, so you would have to actually wait. Hold on. What? It selected everything. Interesting.
We have a pandas master here. Yeah, I think it needs to be a tuple. Good point.
Yeah, it might need to be a tuple actually. Instead of a list. No, if you take out the colon, it works.
Yeah.
Gosh. The colon is messing things up because it's a series and not a data frame. That's why it's like if you take off the points part, like all this would work. I think.
Yeah.
Are the notebooks for the live lecture recap posted anywhere? They'll be posted after this is over.
Yeah, we'll post them on the class website.
Why would we want to multi-index a data? Hold on. Should we use lock? Can you lock a series? Yes, you can lock a series. So you can just like, yeah, it would work like, except you got no more columns because you only have one column. Let's see. Let me make sure I get everything. A lot of questions. Why would we want to multi-index a data frame? So multi-indices come naturally as a result of grouping by multiple columns. So that's why like we're going over this to like see how you can work with multi-indexed like data frames or series.
And I believe in Lab 4, you have a multi-indexed series where you group by CV, legend, and defense or something.
Yeah.
Why would this be useful? Well, because this tells us directly what the average points per game for Atlanta small forwards is, for example, or Washington centers is, right? If we wanted to, know what these kinds of things are, grouping by multiple columns will tell us that. Another, way we could use this is we could, perhaps do dot count. Oh, so dot count dot size. This is a tricky question that people also got stumped on. Dot count returns a data frame. Dot size returns a series. But suppose we wanted to know how many, power forwards there are listed for Washington, we could do this, and you need to group on both of these things.
There's a subtle difference between size and count besides that you can Google if you want, but it's similar to like
that's actually a question on the lecture 7.
Yeah.
It has to do with missing values.
Yeah, it's similar to the difference between like count star in SQL versus count like of a particular column that has null values.
Yeah. That's kind of a tangent.
Tangent.
Oh yeah, here.
Yeah. So there's a question: can we do dot loc, comma ATL? Yeah. So change SF to colon. I believe you can do that. What?
No, because in a tuple, this is not valid.
Oh yeah. In a tuple, it doesn't know. It doesn't know what colon is. All right.
Yeah. So I guess you can't do that.
You can't do that. So the reason like all the like the second argument stuff was erroring out earlier is because this is a series and not a data frame. So if you tried doing it on a data frame, I believe it will work. Yeah. So we can also essentially select all the small forwards by using the colon on the first argument instead of the second argument. So this line of code here would just select all the teams, but only the small forwards from all the teams. So this gives you like the average points for all the small forwards of all the teams. Yeah. Okay. Any other questions? Sorry, that was a bit of a mess. So generally, when we have multi-index data frame, we should avoid using loc. You can use. I don't think that's necessarily true. I think the reason we were having a bunch of issues was because we were like operating on a series instead of a data frame. But there was that one issue that is actually relevant in that you can't like use colon as a part of a tuple, while you can use colon like just by using regular indexing here. So that is a valid concern. But generally when you're working with data frames, even if they're multi-indexed, like you can still use loc. Like that's not necessarily a bad idea.
We never actually looked at a multi-index data frame. We've only been operating on the points column, which is a multi-index series. I guess I shouldn't say never because we briefly looked at it, but this is a multi-index data frame.
And we can do like loc on this. Like you can select the Atlanta, the rebounds, or like the average age for Atlanta power forwards or something if you want using loc.
Cool.
All right, that was a lot. All right, so merging. All right, it's already 4.
Let's just finish up the merging.
Let's finish up merging real quick. Okay, so this is just some other separate data set, college. So this is just some random data set of college players and like their like how many, like their points or like what college they went to, stuff like that, their height. So there's a ton of columns, but we're gonna focus on like the name column here. So it's actually not true that the name column is like primary key. There's actually like people with like the same name, for example. So that's just one thing we'll watch out for later. Scroll down. So we can do by default, Pandas merging is an inner join. So you see that in like the first line of code, there's no like how argument, but by default, Pandas is an inner join. So we could just merge. This is the syntax for merge. Basically, you take your first table, and then you call dot merge on your second table as the first argument, and then you specify these two arguments left on and right on. Left on is the column you join on the left table, which is like the DF in this case, and right on is the column you join on in the right table, which is college in this case. And then we just select a bunch of columns in those tables, in the join table. And this is what we get. So we'll see that, run the next cell. We'll see that DF has 708 rows and college has 4,576 rows. And we do an inner join. Like there's some rows that don't match. So it makes sense that there are fewer rows than the original DF data frame as the result of the inner join. But we can also do a left join, which is, again, the same as like a left join in SQL, where we keep all the rows in the left table and we join in like the values in the right table. So in this case, DF is the left table. So we keep all the rows in the left table and we join in the matching values in the right table. And if there are no matches, then the results are nans, I think, in the case of Pandas. So if you run that, yeah. It'll be nan if there's no matching record in the right table. So an interesting point is that there's 714 rows. Yeah.
One thing I wanted to point out is that when we did a left join, Alex Abrinas has a nan for college and NCAA points per game, because I guess he doesn't appear in the college data frame. So because we did a left join and he's in the original NBA data frame, he appears in the result. But since we don't have college data, there's a nan here. When we did an inner join, he didn't appear here. Sorry, you were saying?
Yeah, so one interesting point is there's 714 rows in this left join, but there are only 708 rows in the original like DF data frame, which was the left table that we joined, that the left table as a part of this join. So why could we get more rows as the result of a left join? I think a lot of people got this question, or like a related question, wrong on the quick check as well. So why can we get more rows? They appeared more than once in the right table. Yeah, exactly. So if I had, for example, let's just take a random player, Tyler Zeller. If he only appears once in DF, but he appears twice in college, then the result of the join, there will be two rows corresponding to Tyler Zeller. There'll be Tyler Zeller 1 corresponding to the first record in the right table, and Tyler Zeller 2 corresponding to the second record in the right table. So although there was only one record in the left table, because there were two records in the right table, when I did a join, the result is two records.
So the duplicates for Zubats were there in the original data frame, because that's just how Basketball Reference, stores stuff. So there were already 3 from that. That's not a result of this merge. And this is just us calling, dot value counts on college name, and you can see that players appear multiple times. So let's just, we're not doing that today. Let's just see what happens if we say, all the rows where the name is equal to this. So now with the space in it. You can see these are all actually different people. They're not the same person appearing multiple times. They're like, one was born in 1957, one in 1962, and one in 1975. So there are 3 different Charles Joneses. If there's only one in the NBA data frame, the result of the merge will give us 3 of them. And so part of the flaw with how we were doing this is we're just going on first name, which is not, or sorry, name, which is not a primary key. Because clearly here, there are 3 Charles Joneses. Regarding what I said, why is Alex Abrina's case different than Zubat's? It's very subtle here, but it's because in the college data frame, Alex Abrina's, his name doesn't have an accent on the first letter of the A. But in the NBA data frame, for whatever reason, there's an accent on the A. So it doesn't matter. Yeah, it's kind of weird there. Yeah, data cleaning, yeah.
Yeah.
It shows you why that's important.
Yeah, also the importance of like primary keys and like foreign key references to primary keys.
Yeah. Cool. I think that's all the time we have for today. What we were going to do was walk through the extra regular expressions practice that's linked on the website, but the notebook and its solutions are here, so you can sort of work through this on your own. And in discussion on Monday, you will get practice on regular expressions as well with the GSIs. Any last questions for us before we call it a day? Alan, anything else?
Nope. Midterm content. So the logistics post, I think, will come out like today or tomorrow. But the scope is like lectures 1 to 10, I believe, right, Serge?
Yeah. So it's lectures 1 to 10. So everything through next Tuesday will be in scope. And the lectures on Monday and Tuesday are visualization, which you've kind of started working on in Project 1 and Lab 4, but we will formalize some of the things you've seen. But it's not going to be something, completely foreign. Well, part of it will be. Would summer 19 midterms be good practice? Not exactly. I wouldn't say so.
I think it's okay.
It's not any better practice than any other midterm.
Yeah,
It's not better just because it's a summer.
Yeah.
What will the format be? Let's wait until the logistics post comes out. That will answer those types of questions. What would be good practice? Go for it, Alan.
Well, my recommendation is always past exams. Most of the midterm ones are good. Some of the like semesters where there were only one midterm, there's going to be a lot of content that's out of scope. But for most of the midterm ones, those are good practice. The only thing out of scope from midterm ones would be PCA or like dimensionality reduction. So those are not in scope for like our midterm one, but they might appear in other midterm ones. Did you have anything else there?
Not much other than that we will have, past exam threads on Piazza, and you can ask questions about these old exams. And there we can discuss what is and isn't in scope from an old exam. Stop screen sharing.